Okay, welcome back. So we're going to do another Laplace transform. This one I want to do it almost fully with the computer. Okay, so we're going to start. We're going to take the Laplace transform of e to the negative 2t cosine square root of 3t minus t squared e to the negative 2t. That's of s, and that's going to be by linearity. That's going to be the Laplace transform of e to the negative 2t cosine square root of 3t minus the Laplace transform of t squared e to the negative 2t. Okay. Of s. Okay. Now, we're going to have to find what is the condition that we need on s first. Okay. So we're going to take, let's take, for example, if we were to do the integral from 0 to infinity of e to the negative 2t e to the negative st dt. Okay. So in order for that to work, we need s, well, let me rewrite that. Let me rewrite that as the integral from 0 to infinity e to the negative s plus 2t dt. In order for that to converge, we need s plus 2 to be greater than 0. So s would need to be greater than negative 2. So this is the assumption that we're going to need to put in. Okay, so let me go ahead and go to my Sage notebook, and we're going to compute these Laplace transforms. Okay, so yes, I gotta stop. So Laplace transforms, share. Okay, so this is what we had before. Okay. Okay, that's what we had before. Now, what we're going to go ahead and do, we're going to go ahead and compute those two Laplace transforms. I have them written down. I hope you have them written down somewhere. Okay, so I'm going to go ahead and change my assumption first. My assumption is s should be bigger than negative 2. My f of t. Now, granted, I could just do them both together, right? But that would kind of take the fun away. I don't want to do that. So I'm going to do each one separately. The first function is e to the negative 2 times t. I'd forgotten the negative. I had an e to the 2t the first time, and I couldn't figure out what was going wrong. Times cosine square root of 3 times t. Okay? Now, I don't want you guys to think that, oh my God, what did they do before these? Before these things, students use tables to compute Laplace transforms. Okay? Okay, e to the negative 2t. Okay, that's s plus 2 over s squared plus 4s plus 7. I'm going to write that down. Now, the other function I have is t squared times e to the negative 2t. Okay, so let me change my f of t to t squared times e to the negative 2 times t. Okay, you can see what I'm doing. I just have the integral set up. This is standard sort of thing. That's 2 over s plus 2 cubed. Okay, so now I'm going to go ahead, stop sharing. Share with my other screen, my iPad. Okay, and I computed these things. This was s plus 2 over s squared plus 4s plus 7 minus 2 over s plus 2 cubed. Okay? All right, and this is of course valid when s is bigger than -2. Okay? Now, I was thinking about this. I'm going to mention it as well in the class by now, but I'm going to mention it again. If you use Sage to do something like this on a test or on a quiz, then I'm going to insist you include your code. Okay? All right. I will see you all in the next set of videos. Have a good one.